Hey guys, today we're going to do section 8 of chapter 6. This is the last section of the chapter. And what you see here on this first page are your formulas. Now, it is most helpful if you know your formulas. Look, there's some trig identities down there that are going to be very helpful. If you know these, it's going to be much easier for you to fall right into finding these antiderivatives. And most of what we're going to do today is just examples. We are going to use U substitution again. Antiderivative of 1 over x ln x cubed. U equals ln x. So du is 1 over x dx. So dx is x du. Substitute 1 over x times 1 over, and we can bring that 3 down. Remember your rules of exponent. Rule of logarithms, exponents become number in front become the exponent. So that makes that 3u times x du. So that's 1/3. Antiderivative, x's cancel. Bring the 1/3 out, du over u is 1/3 ln absolute value of u plus c. We have an indefinite integral, so plug that u back in. And even though it looks funny, that is your answer. 1/3 ln of absolute value of ln x plus c. Taking a look at part B, u equals 2 minus 3 cosine theta. du is 3 sine theta d theta. So d theta is du over 3 sine theta. The antiderivative of sine theta over u times du over 3 sine theta. Cancel your sine thetas. 1/3 antiderivative 1 over u du is 1/3 ln absolute value of u plus c. Plug in u. And you have your answer. Feel free at any time to pause the video, try some on your own, and then come back and check your answers. Part C, u is 1 plus sine t. Du is cosine t dt. So dt is du over cosine t. The antiderivative, you should see a pattern here, is the antiderivative of 1 over u du, ln absolute value of u plus c, ln absolute value 1 plus sine t plus c. U is 1/2 x cubed, du 3/2 x squared dx. So dx, you're going to multiply by the reciprocal, and the x squared you're dividing by, so it goes on the bottom. So antiderivative of x squared times e to the u times 2 over 3x squared du. X squareds cancel. 2/3 antiderivative e to the u du is 2/3 e to the u plus c. For part E, u is cotangent x. The u is negative cosecant squared x dx, and dx is negative du over cosecant squared x. Remember that u is going to be something that when you take the derivative of it, it can cancel out what you have. Now, the reciprocal of cosecant, as you see there are no cosecants here, but the reciprocal of cosecant is sine squared. Which is going to help. So the antiderivative of e to the u over sine squared x times negative sine squared x du is the negative antiderivative of e to the u du, which is negative e to the u plus c. And for f, u equals sine x, du equals cosine x dx. So dx is du over cosine x. Antiderivative of 2 to the u cosine x times du over cosine x is the antiderivative of 2 to the u du. Taking a look at your formulas on the front page, the antiderivative of a to the u du is a to the u over ln plus c. So that's 2 to the u over ln2 plus c. Again, knowing those formulas, being familiar with those formulas will be very helpful. Looking at part G, we have another tangent, inverse tangent here. A is going to be the square root of 5. 5, remember, this is squared. So square, in order to get 5, we have to square the square root of 5. U will be 2x, so du over 2 is dx. So we're going to rewrite this as 1/2 antiderivative of du over the square root of 5 squared plus 2x squared. There's your a and there's your u. Answer 1 over 2 square root 5 inverse tangent 2x over square root of 5 plus c. Take a look at those formulas on the front if you need help with that one. And for hu is going to be your inverse sine, and derivative is 1 over square root of 1 minus x squared dx. So dx is square root of 1 minus x squared du. So we have the antiderivative of u over square root 1 minus x squared times square root 1 minus x squared du. Cancel. Antiderivative of u du is u squared over 2 plus c. So inverse sine of x over 2 plus c. And that's squared. All right, we've got changes of bounds here, and you guys have experience with those. Again, if you would like to pause your video, feel free to do so. You're just doing the exact same thing with different formulas. That's the only thing that's different. So we're going to go through these fairly quickly. There's no need to take tons and tons of time on something we've been working on fairly recently, and a lot of it. U equals x plus cosine x. So du is 1 minus sine x dx. dx is du over 1 minus sine of x. All right, we're changing our bounds. So 0 plugged into x plus cosine x is 0 plus cosine 0. So the 0 becomes a 1. And pi over 2 plus cosine pi over 2. 0 plus pi over 2 becomes pi over 2. So your bounds are from 1 to pi over 2, 1 minus sine x over u times du over 1 minus sine of x, pi over 2, 1, 1 over u du is ln u from 1 to pi over 2. So ln pi over 2 minus ln of 1 is ln of pi over 2. Remember, ln1 is 0. Part B, u is 2 minus x, du is negative dx, dx is negative du. Plug in 1 and you get 1. Plug in 3 and you get negative 1. So 1 to negative 1 e to the u du, and it is negative. And then it becomes positive, and we switch to get our bounds correct. So this is going to be e to the u from negative 1 to 1, e to the 1 minus e to the negative 1 is e minus 1 over e. and into your calculator, that will give you 2.3504. Taking a look here at part C, u is 3x to the negative 1. So du is negative 3 over x squared dx. So dx is negative x squared over 3 du. Your bounds, 1 becomes 3, and 3 becomes 1. So your bounds from 3 to 1, e to the u over x squared times negative x squared over 3. Negative 1/3 comes out, but becomes positive when you change your bounds. So that's 1/3 e to the u from 1 to 3 is 1/3 e to the third minus 1/3 e, which is approximately 5.789. And the last one here, part D, u is 1 plus e to the 2x. du is 2e to the 2x dx. So dx is du over 2e to the 2x. Changing your bounds, 0 becomes 2. 3 becomes 1 plus e to the 6th. So antiderivative from 2 to 1 plus e to the 6th. You don't want to round that. Is 2e to the 2x over u times du over 2e to the 2x. 2e to the 2x cancels. So we have ln of u from 2 to 1 plus e to the 6th. Remember, that's absolute value. So ln absolute value 1 plus e to the 6th minus ln2, it's already positive, gives you approximately 5.3093. Taking a look at part E, do have a little bit of sun breaking through here, so I'm going to do my best to keep that out of our problem area there. So u equals x squared, du over 2x equals dx. From 0 to 1, 0 becomes 0, 1 becomes 1, so that's easy enough. Antiderivative 0 to 1 of x times 5 to the u du over 2x. 1/2 antiderivative 0 to 1, 5 to the u du. Remember that formula out front on that first sheet, 5 to the u over ln 5 from 0 to 1 is 1/2 times 5 over ln 5 minus 1 over ln 5, which is 4 over 2 ln 5. And that's 1.2427. And our last example here, I'm just going to scoot it over again to try to avoid that sun. U equals cosine of x. So du over negative sine of x equals dx. 0 becomes 1 and pi becomes negative 1. So I'm going to go ahead and switch that and make that negative. So negative 1 to 1 of e to the u times sine x times negative du over sine x, which becomes positive, which is e to the u from negative 1 to 1. So e minus 1 over e, which is 2.3504. And evaluate by completing the square. We've done a few of these here. So this bottom one, we want this to be, because of that middle term, middle number divided by 2, 6. So we want this to be x squared plus 12x plus 36, which means plus 1 out to the side. for the perfect square and to equal 37. So we have antiderivative of dx over x plus 6 squared plus 1. Pretty good indication you're going to have that trig function, inverse trig function. X plus 6 du is dx. A is 1. So you have your inverse tangent of x plus 6 plus c. And even though you are underneath a radical, you are going to do the same thing here. So you're going to have negative x squared minus 4x and then plus 4. You're going to have to add 4 out to the side because negative 4 and positive 4 would be 0. So we're going to rewrite that. Dx over 4 minus x minus 2 squared, which is your inverse sine of x minus 2 over 2 plus c. Take a look at those inverse trig antiderivatives. Then you've got two fairly quick problems on a change of variable challenge here on the back. What happens if it doesn't cancel? So u equals 1 plus the square root of 2x. So I'm going to solve this for actually the square root of 2x, and you'll see why in just a second. So the derivative of u is 1 over the square root of 2x dx. So dx is the square root of 2x du. Well, there's the square root of 2x. U minus 1 du equals dx. So there's your challenge part. Antiderivative of 1 over u times u minus 1 du is the antiderivative of u minus 1 over u du. Split it up. And that's u minus ln absolute value of u plus c. That made that so much easier to split that problem up. It is indefinite, so you will be subbing back in. U is 1 plus the square root of 2x minus ln absolute value of 1 plus square root of 2x plus c. Now, there is a way to rewrite this so that you don't have c and 1. If we declare c sub 2 equals 1 plus c, then our answer is the square root of 2x minus ln absolute value of 1 plus square root 2x plus c sub 2. And you're going to see those c sub 1s and c sub 2s coming in chapter 7. So going ahead and getting ready for that is not a bad idea. All right, last one, u equals 3x plus 1. Du over 3 is dx. Change of bounds, 0 becomes 1, 4 becomes 13. That's 5 over u times 1/3 du. So I'm going to bring the 5/3 out. 1 over u du is 5/3 ln u. Both my numbers are positive. Say that's 5 thirds times ln 13 minus ln 1. We should know by now that is 0. Answer 5/3 ln 13, which is approximately 6.4124. All right, guys, this concludes chapter 6. Let me know if you have any questions, and I'll talk to you guys soon. Have a great day.